When installing a microwave and exhaust fan combination unit, the recommended practice is to run a separate circuit. Tapping off a number 8 range circuit with number 12 wire is not the correct approach and should not be done. Using one of the small appliance circuits might seem like a convenient option, but it can lead to overloads and potential safety hazards. Let's delve into the reasons why a dedicated circuit is the best choice. Firstly, the National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety and prevent fire hazards. Microwaves, especially those combined with exhaust fans, often have significant power demands. Small appliance circuits, typically rated at 20 amps, might already be serving other outlets and appliances in the kitchen. Adding the microwave's load to an already burdened circuit increases the risk of tripping the breaker, which can be inconvenient and potentially dangerous. Secondly, consider the ampacity of the wires. The number 8 wire used for a ranged circuit is designed to carry a higher current than number 12 wire. Tapping off a number 8 circuit with number 12 wire creates a bottleneck and violates the code requirements for proper wire sizing. Number 12 wire is generally rated for 20 amps, while number 8 wire can handle a much higher current. Reducing the wire size in the middle of the circuit can lead to overheating and insulation damage, increasing the risk of fire. Thirdly, the NEC specifies requirements for appliance circuits. Section 210.23. 8.1 permits 15 and 20 amp circuits to supply lighting units, other utilization equipment, or a combination of both. The total rating of utilization equipment fastened in place, other than lighting units, shall not exceed 50% of the branch circuit ampere rating where lighting units, non-fastened utilization equipment, or both are also supplied. Section 210.23. A2 states that the total rating of utilization equipment fastened in place, other than lighting units, shall not exceed 50% of the branch circuit ampere rating where lighting units, non-fastened utilization equipment, or both are also supplied. However, microwaves are often considered fastened in place appliances, and their power consumption can easily exceed this 50% limit, especially when combined with an exhaust fan. Fourthly, running a separate circuit allows for better control and protection of the microwave and exhaust fan. A dedicated circuit ensures that these appliances have their own breaker, providing a single point of disconnection in case of a fault or maintenance. This isolation can be crucial for safety and troubleshooting. Fifthly, the installation of a separate circuit typically involves running a new cable from the electrical panel to the location of the microwave and exhaust fan. This cable should be sized appropriately for the load, typically number 12 wire for a 20 amp circuit or number 14 wire for a 15 amp circuit, depending on the appliance's power requirements. The circuit should also include a grounding conductor for safety. Sixthly, when installing a new circuit, it's essential to follow all applicable electrical codes and regulations. This includes using the correct wiring methods, properly terminating the wires at the breaker and receptacle, and ensuring that all connections are secure and insulated. It's also crucial to obtain any necessary permits and inspections to ensure that the installation meets safety standards. Seventhly, consider the future. Even if the existing small appliance circuit seems adequate for the current microwave and the exhaust fan, future upgrades or additions to the kitchen might overload the circuit. Running a separate circuit now provides flexibility for future electrical needs. Eighthly, the power requirements of microwaves can vary depending on the model and features. Some high-power microwaves can draw a significant amount of current, especially when used in combination with the exhaust fan. A dedicated circuit ensures that the microwave receives the necessary power without affecting other appliances on the same circuit. Ninthly, consult the manufacturer's instructions for the microwave and exhaust fan combination unit. The manufacturer typically specifies the recommended circuit size and wiring requirements. Following these instructions is crucial for ensuring proper operation and safety. Tenthly, consider the type of breaker used for the circuit. A standard circuit breaker provides overcurrent protection, but a ground fault circuit interrupter, or GFCI, breaker provides additional protection against electrical shock. GFCI protection is often required in kitchen areas, especially near sinks and water sources. Installing a GFCI breaker for the microwave circuit can enhance safety. When running a separate circuit, several factors must be considered to ensure a safe and compliant installation. The selection of the appropriate wire gauge is paramount, as it dictates the circuit's capacity to handle the intended load without overheating. Number 14 American wire gauge, or AWG, wire is commonly used for 15 amp circuits, while number 12 AWG wire is suitable for 20 amp circuits. The choice depends on the specific power requirements of the microwave and exhaust fan combination unit as specified by the manufacturer. The length of the wire run also influences the wire gauge selection. Longer runs experience greater voltage drop, necessitating a larger wire gauge to maintain adequate voltage at the appliance. Voltage drop can lead to inefficient operation and potential damage to the appliance. The NEC provides guidelines for calculating voltage drop and selecting the appropriate wire gauge to minimize its effects. The type of insulation used on the wire is another critical consideration. Thermoplastic high heat resistant nylon coated, or THHN, and thermoplastic wiring, or TW, are common types of insulation used in residential wiring. THHN insulation is rated for higher temperatures and is more resistant to moisture and abrasion, making it a preferred choice for many applications. The NEC specifies the allowable ampacities for different types of wire insulation depending on the temperature rating and installation conditions. The circuit breaker serves as the primary overcurrent protection device for the circuit. It is designed to trip and interrupt the circuit if the current exceeds the breaker's rating. This prevents overheating of the wires and potential fire hazards. Selecting the correct breaker size is crucial for ensuring proper protection without nuisance tripping. The NEC provides guidelines for sizing circuit breakers based on the ampacity of the wires and the load served. A 15 amp breaker is typically used for a circuit wired with number 14 AWG wire, while a 20 amp breaker is used for a circuit wired with number 12 AWG wire. The breaker should be installed in a panel board that is properly grounded and bonded to the electrical system. Grounding provides a low impedance path for fault current to return to the source, allowing the breaker to trip quickly and clear the fault. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. The receptacle used for the microwave and exhaust fan combination unit should be of the appropriate type and rating. A standard 15 amp or 20 amp receptacle is typically used depending on the appliance's plug configuration. The receptacle should be securely mounted in a junction box and properly wired with the correct polarity. The grounding conductor should be connected to the grounding terminal on the receptacle and to the grounding system. A GFCI receptacle provides additional protection against electric shock by monitoring the current flow in the circuit and tripping if a ground fault is detected. GFCI protection is required in many areas of the home, including kitchens, bathrooms, and outdoor locations. The NEC specifies the locations where GFCI protection is required. The wiring method used for the circuit should comply with the NEC and local electrical codes. Non-metallic sheet cable, or NM cable, is commonly used for residential wiring. NM cable consists of two or more insulated conductors and a grounding conductor enclosed in a non-metallic sheath. The cable should be installed in accordance with the NEC requirements for support, protection, and routing. Conduit such as electrical metallic tubing, or IMT, or rigid metal conduit, or RMC, can also be used for wiring. Conduit provides additional protection for the wires and is often required in certain locations or applications. All wiring connections should be made in approved junction boxes or enclosures. Junction boxes provide a safe and secure location for splicing wires and connecting devices. The NEC specifies the requirements for junction box fill, which limits the number of wires and devices that can be installed in a box. All connections should be made with approved connectors and should be properly tightened to ensure a good electrical connection. Before energizing the new circuit, it is essential to test the wiring for continuity, shorts, and ground faults. A multimeter or continuity tester can be used to verify that the wires are properly connected and that there are no shorts between conductors. A ground fault test can be performed to ensure that the grounding system is functioning properly. After testing, the circuit breaker can be turned on and the microwave and exhaust fan combination unit can be tested for proper operation. If any problems are encountered, the circuit should be de-energized and the wiring should be inspected for faults. In summary, running a separate circuit for a microwave and exhaust fan combination unit is the recommended practice for ensuring safety, preventing overloads, and complying with electrical codes. While tapping off of existing circuits might seem like a shortcut, it can lead to potential hazards and should be avoided. Following the NEC guidelines and consulting with a qualified electrician can ensure a safe and reliable electrical installation. When determining the appropriate wire size for a new circuit, several factors must be taken into account. These factors include the ampacity of the circuit, the length of the wire run, the type of insulation used in the wire, and the ambient temperature. The NEC provides tables that list the allowable ampacities for different wire sizes and insulation types. These tables are based on the assumption that the wires are installed in a raceway or cable and are not subject to excessive heat. If the wires are installed in a hot environment, the ampacity must be derated to prevent overheating. The length of the wire run is also a critical factor in determining the appropriate wire size. Longer runs experience greater voltage drop, which can lead to inefficient operation and potential damage to the appliance. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate the voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant for the wire material, I is the current in amps, D is the distance in feet, and circular mils is the area of the wire in circular mils. The constant for copper is 12.9 and the constant for aluminum is 21.2. The area of the wire in circular mils can be found in the NEC tables. Once you have calculated the voltage drop, you can compare it to the allowable voltage drop to determine if the wire size is adequate. If the voltage drop is too high, you will need to increase the wire size. The type of insulation used in the wire also affects the allowable ampacity. Different insulation types have different temperature ratings, which affect their ability to dissipate heat. The NEC tables list the allowable ampacities for different insulation types at different temperatures. If the wires are installed in a hot environment, you will need to use a higher temperature insulation type or derate the ampacity. The ambient temperature also affects the allowable ampacity of the wires. The NEC tables are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, you will need to derate the ampacity. The NEC provides tables that list the derating factors for different temperatures. In addition to the factors mentioned above, you should also consider the future needs of the circuit. If you anticipate adding more loads to the circuit in the future, you should choose a larger wire size to accommodate the increased demand. It is always better to oversize the wires than to undersize them. Undersized wires can overheat and cause a fire. When in doubt, consult with a qualified electrician to determine the appropriate wire size for your application. They can take into account all of the relevant factors and ensure that the wiring is safe and compliant with the NEC. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. If you are not comfortable working with electricity, do not attempt to do it yourself. Contact a qualified electrician to perform the work. Always ensure the power is off to the circuit before you start any electrical work, and follow all safety precautions. By following these guidelines, you can ensure a safe and reliable electrical installation for your microwave and exhaust fan combination unit. This will help prevent overloads, reduce the risk of electrical shock, and ensure that your appliances operate efficiently. Always prioritize safety when working with electricity, and do not hesitate to seek professional help if needed. Proper wiring and circuit protection are essential for the safe and reliable operation of electrical appliances.